So for our warm up today, so we've got hot water dripping through a coffee maker, filling a cup of coffee. It is filling the cup from 0 to 6 minutes. The function C of t is differentiable. T is measured in minutes. C is measured in the ounces of coffee in the cup, and is given by the table above. Use the data in the table to approximate C prime of 3.5. So C prime of 3.5. 3.5 falls in here, right? So when you're doing approximations of a derivative, you go up one, down one, and do slope. So it'd be 12.8 minus 11.2 over 4 minus 3. Right? And then if you do that, you get 1.6. All right. We need units, right? It says include units. So these are the units for C prime. C is in ounces. Think of C prime not as C prime. Think of it as dC dt. So it's the units of C over the units of T. What would the units be? Ounces per minute. Ounces per minute. Does that make sense? This one was graded literally a point for your approximation and then a point for the units. So if you didn't know how to do the approximation, if you just wrote, what did we always say, 6?
Yeah.
I think that was Naomi's thing,
No,
right?
no.
Yeah. If you just write 6 and then put ounces per minute, you still got the point for the ounces per minute, right? So anytime you have a question that says include units, always put an answer with units, right? Because the answer could be wrong, you still get the point for the units. The point is a point, right? And remember, guys, this point is the same thing as a point on multiple choice, right? Writing ounces per minute, that's worth an entire multiple choice question. Yes?
Could you just write like the units without an answer?
I honestly am not
I'm not
sure
really
if they would
sure.
take that, but I wouldn't take the chance.
Well, yeah, that's my point.
Yeah.
That's
Yeah.
just,
Okay.
You're like pi ounces per minute,
so.
All right. Is there a time from 2 to 4 at which C prime equals 2? Quick review on theorems. You have EVT, IVT, and MVT. EVT, extreme value theorem, says that any function that's continuous on a closed interval has to have an absolute max and an absolute min. That's extreme. It has to have extremes, right? That's why it's called the extreme value theorem. Intermediate value theorem says to get from one point to another on a continuous function, you have to hit every y value in between at least once. And mean value theorem says that to get from one point to another on a continuous and differentiable function, there has to be at least one spot in between where the slope of the tangent is equal to the slope of the secant. So, whenever you're doing a problem and it looks like one that would probably be a theorem kind of a problem, if the problem is asking about a derivative value, it's probably a mean value theorem question. If it's asking about just a y value, like is there a spot where there were 10 ounces of coffee in the cup, right? So just a plain old y value, that would be an intermediate value theorem question. You'd say, yes, because at t equals 2 is 8.8 and t equals 3 is 11.2 to get from here to here, you gotta pass through every y value in between. Yes?
Would you be able to apply the intermediate value theorem to derivatives as well?
Yes, as long as you know that the derivative is continuous.
Okay.
So, but you have to be careful about that because you don't know if the derivative is differentiable. You know what I'm saying? So, for mean value theorem to apply, the function has to be continuous and differentiable.
Well, no, like not the mean value theorem, but the intermediate value theorem.
So, but if you're doing intermediate values, like where, say like you found slope and then another slope and said that it had to hit all the slopes in between,
Yeah.
right? That, I think, would be okay. I think that should be acceptable because this function is continuous and differentiable, and so that the only thing that's required in IVT is that the function that you're talking about be continuous, which would be the derivative, which is continuous. So yes, that should be okay.
Okay.
Yeah. It's not on their scoring guidelines, but that doesn't mean that it wasn't accepted.
Okay.
It's just not, the scoring guidelines that they published are just like small snapshots of what they actually accept. So for this, just so you know, when you use MVT, somewhere in there you need to write that your function C is continuous and differentiable. Then you have to actually find slope of the secant, right? So then you go slope of secant. So C of 4 minus C of 2 over 4 minus 2, and you get 2. As long as the function is continuous and differentiable, the slope of the secant is 2, therefore by the MVT, there has to be at least one place where the slope of the tangent is 2. You do have to name the theorem by name. I once asked a reader if you had to name the theorem by name, right? I said, if a student says C is continuous and continuous on the closed interval 2 to 4, differentiable on the open interval from 2 to 4, the slope of the secant from 2 to 4 is 2. Therefore, there must be at least one place where the slope of the tangent is also 2. But they didn't name the theorem, and I asked if they would get credit, and the answer was no, they have to name the theorem. Yeah, so you have to know your theorems by name. I know. So, I don't know.
Copyright and mean value.
So anyway,
MVT
MBT is fine.
Whenever you do niche.
Although, I gotta tell you, on the actual AP exam, I would never
Be
read
in every
these,
single.
just to be safe.
That's what it works.
Okay, let's talk about midpoint sums. The big discussion today with a midpoint sum with 3 subintervals. 3 subintervals just means 3 rectangles, right? Yeah, midpoints, left, right, and midpoint are all rectangles. Yeah, the only shapes that we approximately vary with that aren't rectangles are when we use trapezoids, right? Okay. Yeah, so I went ahead and drew the 3 intervals on here, right? They had to be equally spaced. So we're going 0 to 2, 2 to 4, 4 to 6. So the big dilemma today was, is a midpoint rectangle, we know the width, right, for all, what's the width for all 3 rectangles? It's 2, right? So really it's the heights that we're concerned about. Is the height for a midpoint rectangle the average of the y's, or do you average the x's, find the midpoint, and find the y value at that spot?
Average the x's, find the y value.
Y value at the midpoint.
Uh,
5.3.
Average the x's, find the y value.
Why not both? You get different answers depending on how you do it, right? There can only be one correct one.
But unless you average the 2 averages, and then you can
Have a third wrong answer.
Okay, so,
Guess in chat.
let me just mention this to you. Let's just think of it this way. The y values are the same as the lengths of the sides on each side of the rectangle, right? Okay? If I take the average of the y's, what I'm really doing is taking this base plus this base and dividing by 2. What shape has an area where we take the width times this base plus this base and divide it by 2? That's a trapezoid. You just found the area of a trapezoid. A trapezoid's area is really just the area of a rectangle where the height of the rectangle is the average of the 2 y values, right? So when you average the y's, you're doing trapezoid rule. Midpoint rule is what is the height at the midpoint of the interval. It's the average of the x's, right? So when you are doing midpoint, you would have a width of 2. You can put 2 times each individual one or just put it out front. But what would be your first height?
5.3.
5.3. Next height?
11.2.
11.2. Next height?
13.8.
13.8. Now, this is a no calculator question. Should I simplify that?
Yes.
No. Right? Numerically equivalent to correct is correct. You leave it and walk away. Right? Okay. All right. Now we have to explain this thing. Hey, take a look at this. 1/6 integral 0 to 6 of c of t dt. What formula, or some people also call it a theorem, is that?
Intermediate value. For the average value.
That's average value.
Sorrow, not the intermediate, the average.
Yeah.
Yeah, it's, there's, oh, no, no, no,
Hold
no,
on,
no.
Mark.
Oh, shh.
For the
Yes, guys, this is just the midpoint Riemann sum part. We had to approximate this. Which part of that is approximated by this guy right here? Is it the entire thing, or just the integral portion? Just the integral portion. Yes, so for this actual answer, woo, wow. That's good. I can do this. Wow, it's really wanting me to grab it. There we go. Ah. Okay, so for this actual approximation, you'd need to put a 1/6 out front. Right, and that would be your approximation. All right, so this is the average value of what? What is it averaging?
The amount of the
Amount of coffee.
It's the amount of coffee. It averages whatever is right here, right? So this is the average value of C. So it's the average value of the amount of coffee in the cup at time t. So what this is really saying is the average value, or the average amount of coffee in the cup from 0 to 6 minutes is whatever you got, ounces. Does that make sense? Yeah. Okay, good, good. Okay. All right, last one. The amount of coffee in the cup in ounces is modeled by this function right here. V of t, 16 minus 16e to the negative 0.4t. Find the rate at which the amount of coffee in the cup is changing when t is 5. So we really need to find v prime. That's gone, so you get negative 16 times negative 0.4 e to the negative 0.4 t, right? Okay, and then your rate, blah, 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 when t is 5, so you just put a 5 in for t. So if we were being good students, you would write that and stop. We don't simplify.
Wait, why?
Make sure you do it right.
I
Okay,
trust
are you
myself.
sure?
Yes.
Did you get positive 6.4 over e squared?
Why
Yes.
did the fraction? I did 32/5.
I got 32 divided by 5e squared.
Oh, okay, yeah. Wait, did you get 32 over 5e squared?
Yeah.
Okay,
Hey,
yeah, that's,
You do.
all right, good.
what?
Woo, that's a big slide. All right, at the end, so it's time to do our lesson. You're gonna like this. So, integration by tables.
Yeah.
It's not hard.
Yes, it
I just
is.
don't know if you're gonna see a lot of value in what we're doing. Evaluate integrals using a table of integrals.
We have a calculator.
We're gonna take.
Okay.
if it's
Before we get into the new stuff that we're learning, let's do a tiny bit of review. So I want you to take a minute, you work together, and see if you can evaluate all 3 of these integrals. Each of them have similarities and each of them have differences. But they can all be integrated using methods you know.
Yep. Give you my part.
Maybe that's a sign that we're not supposed to be throwing good
Hey, don't push my stuff, right? Oh, wait. You want to repeat that number?
Yeah, you don't even have to ask.
Is it minus or plus the interval? It's minus. Get that camera there.
I don't know what's going on. Just
Really?
Yeah.
Nosebleeds
Or do
happen
you?
a lot more often in winter because of all the heat that goes through, the air dries out really bad, and then
My nose gets so dry, like I'll be in the shower and all of a sudden it'll
Yeah.
just start bleeding.
Yeah, it happens.
If it starts bleeding, you got no will, so that it doesn't bleed. Trust me. Trust me.
I got one
So I'm just sitting there for the water.
Yeah, it happens. Use the first one, right? Minus the integral of du. There you go.
X squared over
What about the
then
second?
u.
What about the third one?
Oh, like stick your hands, like, yeah, and then.
Do so too.
X over
And then
two.
Just one over here.
What?
ln of ln.
Those two, your u and
No, you just do ln.
of
Oh,
ln.
yeah.
Oh, is that one?
If you do ln of ln.
X squared.
ln of ln. So you need b. You want to
Talk about the first one.
X squared natural log. X squared over 4 plus.
Yeah, that's right.
One that was like.
Wait, no.
The second one is just
Do you know how to do
It's
this?
u v minus the integral.
Oh.
Very good.
Cool, you get answers?
Yeah.
Because you do kitty corner.
Yeah, 1 minus ln.
Cool. Oh, you Tommy. Thomas guy, he was kitty corner.
He just kept
I
saying
needed to
like,
die, but it was
over
just
and over.
that's how I remember kitty corner. I have no idea what it meant, where it came from.
Yeah, I did.
Just one with it.
Yeah, he's like, well, this times is in the kitty corner. Perfect sense. I didn't understand it, but it's somehow,
Like cats. Cats are in corners? Is that a stereotype?
So dv equals x dx.
Plus c.
Yeah, I am incredibly forgetful.
I'm just saying, because Mr. Thomas would like make up words and stuff, and like kitty corner, and skippy, or.
No, kitty corner is an actual.
That's a word.
That's a word. Oh, because you just say it and nobody knew what it meant.
Oh, kitty corner means diagonal.
Oh,
I grew up with that term.
I never did.
No, the word for kitty.
I was saying I can always remember the diagonal because it's a kitty man.
My friend Bob had lived in the house kitty corner to mine. That's right. I remember saying that when I was little. Kitty corner, diagonal.
Hey, what does it mean?
Okay, first one. I don't know why though.
I never
Kitties in corners, how it goes diagonal.
different. Like when he was like
Oh, like a
guess it's just
kid's
a-
corner.
Yeah, it could be a kid's corner.
I'm pretty sure it is.
There was like, hey, go to the kitty corner.
Alright, we gotta find down for a minute. For the first one, what method did you have to use?
Parts.
Parts. Parts is parts. Good. Alright, check your answers. Any questions on that one? I'm happy to show you the setup. Yes? Okay. So for integration by parts, whenever you have a natural log integration by parts, you want your u to be the log. So then your dv is the other stuff. And that way when you do your v, so the integral of x, 1/2 x squared, and then when you do your du, the derivative of ln x is 1/x. Ah. The derivative is 1/x dx, right? Remember, integration by parts, if you have the integral of u dv, it equals uv minus the integral of v du. Right? And so you end up with 1/2 x squared ln x minus 1/2 x dx, and then you just do the integral of the x. Does that help? Yeah? Okay. Next one. What method?
You sub.
Straight up u sub.
Straight up.
You do it with guts. Last one. What method? U sub. This one was a U sub with a power rule. This one was a U sub with a natural log. How'd you guys do on these? Good. Any questions? All right, let's talk about what we're doing today.
Nice hands, Pete.
Integration tables. These are kind of cheat sheets for integrals. What they are really are tables in the back of your book, and they're in the back of just about every calculus book, that basically they're like formulas for every type of integral you can encounter. You could just memorize all 100 and whatever there are of them, right? And never have to do an integration by parts again because you've memorized all those formulas, right? Okay. But, yeah. So anyway, but what we're going to do today, you'll just, quick note, you will never ever be allowed to use the actual integration tables on any quiz or test or the exam, right? Yay, okay. So what today is for, so what today is for is really, it's just kind of a day, just so you are aware of them. That's real all it is. It's Integration Table Awareness Day. So here's what we're going to do. Wait. I'm gonna take that down. Okay. So for the first one, if you don't have your book with you, go ahead and get out like maybe one per pair. You don't have to every single person have a laptop up, but maybe one for every pair. Open up your laptops. Go to my website.
Yep.
Alright, so if you're on my website, go to, there we go. Go to Integration Techniques. The only worksheet we have in there so far is this little scan that I made of the tables out of your book. So I literally, it's probably illegal, but I literally just took those pages, scanned them in, and put them on the site, right? Yeah, so there you go. These are all the formulas, right?
Wait, where is it?
It's in our website.
Yeah.
Price. Oh wait.
Hey, there's exactly 100.
Where's the integration table?
Oh yeah. By the way, Miss Price,
And
it's
you don't
not.
even have to learn all of these, because these are functions we're not dealing with. So you'd only have to memorize 91.
Oh, by the way, Miss Price, it's not illegal to scan anything.
Yeah. It's not as hard as you'll think. It's really not. Okay. Quiet, calm down, guys. So, if we take a look at the first example, just a quick note, there is no formula that has x squared square root of ax squared plus b. You need to get this coefficient out of there. You need this and this to match for the formula to work. So the way that you pull a coefficient out of a root, think of it as like pulling a root 9 out of both terms. So what I do when I'm doing this one is I pull that root 9 out and treat it like this. I want you to take a minute and see if you can find the formula that you would use to integrate that function, and then see if you can write the answer. It's actually shorter than you think. They're grouped kind of logically.
Wait, what?
Yeah, the answer is not short. The answer took me 2 lines to write.
Is it a road?
I think it's number 27. Is it? Yeah.
Oh, it's not that.
Well, you just make it a square root.
Yeah, so that's what
27. Oh, there it is.
Yeah, 27.
Wait, yeah.
I got it. Already. 1-8. That's 1-8.
Yep.
She doesn't answer.
Wait, 1-8 what? You're zooming out.
Wait, no, that was, yeah.
What is you? What's you?
Because of you and Eli.
Hey, if we were doing this problem, what method would we have to use by hand?
An integration.
Trig
Yes,
sub?
exactly, triangles, trig substitution, right? You have square root and quadratic?
No, what's the integration table?
The A is, you have to take out a 9.
Square root of 2 over 3.
A squared
No,
2.
no, it's 2 over square root of 2. No, 2 over square root, 2 over 3.
Isn't A just 2
No,
nines?
not square root, it's just 2 over 3.
Well, A is 2 nines, square root of 2 squared.
Oh, yeah, you're right.
Square root of 2. Yeah. A is 2 nines, so then it's...
Probably 2.
Why is there there's no A is 2 nines?
Because it's A squared. You have to have A squared.
Yeah, so you have to take out the 9.
Because
Okay, but then right here, A squared is still 2 nines.
A squared is root 2 over 3.
A squared is 2 nines.
A squared is 2
2
nines.
You never need just A.
A is but A squared is 2 nines.
Well, you have.
Yeah, because look at that. The original here.
No, that's true.
The
A
original-
squared is 2 nines.
Oh.
Yeah, A squared is 2 nines.
Yes.
Yes.
But you were saying that A was 2.
Oh, was it?
Well, yeah, A squared is like 8.
This.
But
But
you
yeah,
already
yeah,
know it.
So I have this
So it's
down.
x squared plus
Now I have to
2
convert
nines.
it.
And then
Okay.
Oh,
minus
yeah, you never need a number.
minus a to the 4th, so 481st ln x plus
How'd you do?
x plus.
Good enough.
Alright, next one.
Are we
Not every integral matches exactly with something in the table. So sometimes you might have to do a little u substitution before you can find a matching integral in the table. For this one, what would you let u equal?
E to the
E to the x, right? And be so careful about when you substitute that un. Think about du, right? So that you don't start putting in too many u's.
It's not 1, it's u over.
No, it's
Always
one.
one.
Because, but no, but EX.
Oh, you can take it out.
No, because e to the x, the derivative of that is e to the x dx, which you have up there, so that just turns into 1 over
Right,
1
but when
minus
you,
10.
when you replace it.
Am I on the right track?
1 minus tan.
No, it's just 1.
I haven't noticed one, but that doesn't mean there aren't people. There are.
Oh, because you
Would it really make your life
Spell
better?
yourself.
No, not at all.
No, wait.
Okay.
Alright.
Isn't du equal to?
I'm
Checking
sure
the
it could be
80s.
done. I
Yeah,
had
the
students
where the
years
E-
ago who memorized the
No,
first two.
your u's only e to the x.
So
Probably
high.
just one minus e to the
No
x
purpose, but he did it.
So dude, it's u over 1 minus u.
I feel
No,
like
u over 1 minus. No, 1 over 1
Yeah,
minus
yeah.
This price.
We pulled up high once though and made him stand in front of it and then checked him while he was reciting.
Why did the kid even bother memorizing that many digits of pi?
I remember in
Wait, is it 71?
I think I got you like 70 or something.
No, it's not 70. Who's this? No, Claire. You guys know like Isaac Sorensen?
Oh my god, yeah.
He had over 200 in like in 5th grade.
200, but then I remember he had like jet lag or something.
Sure.
I was really disappointed. I thought he
Dude,
was-
give me a minute.
Yeah.
Please.
Dude, it smells really good here. Oh, can I take it? I don't know, it just smells really weird.
They just, yeah, they just use the back of the for no reason.
It tastes fine. Right, what are you doing?
Alright, did you guys get this one? When you do your u sub, that's the function you get.
What?
Did you get a 1 on top, not a u? Good, that's really important. Alright, did you all find the formula?
See?
What formula did you use?
71.
Did you use 71? Yeah. Good. Good. And there it is. I copied the wrong sign down. Be careful, like, that your eyes,
Sounds
when,
weird though.
if your sign is plus, you follow the pluses, and if your sign is minus, you follow the minuses, if it's a plus or minus kind of a thing. So be careful, don't let your eyes accidentally wander between the signs, right? All right, any questions on that one?
But
Yes, Chris.
don't some integrals have like negative ln, like cosecant theta or like cosecant x? So like, how would you know the sign?
Oh, because it tells you in the formula. Do you see it?
I'll look for it though.
Okay.
No, you go down there plus or minus, and then if it's plus,
It depends.
it's just a rule, just trust it.
This is truly just a formula. You're not deriving it. If we were to do this from scratch, right, then we'd have to do something different. You're not deriving the rule. Right? I actually wonder if this would be like multiply top divided by the conjugate kind of a thing, right? So, anyway.
Probably have like minus.
Alright, here's a fun one. We did this one in first and third
Oh
today,
yeah,
and
it's an upside down symbol. So
oh,
they'll
that's
put
an
minus-
upside down?
Yeah.
Okay.
So if it's.
Alright,
yeah,
that's why.
that makes sense.
And I discovered that a number of students were not versed in tabular method. I know. So, here's what I want you to do. I want you to take a second, find the formulas on your table for this, and then I'm gonna take a minute and redo the problem using tabular method, and I'll put it in the slides just so that everyone is familiar with tab method, because it is kind of fun.
It's like you have a polynomial. I was so confused when I asked somebody like
Wait.
if they knew tabular method from Thomas last quarter, and they said they didn't even learn it.
No, it was in the homework
okay.
one.
It's my
It's
favorite.
not
This is the
required.
formula.
It's way better than my
Yeah.
rules.
My parts is evil. Tab method on the other hand is good.
Is it? I agree.
Am I ever wrong?
You're the real OG. You know that?
So like instead of doing
Okay,
I
yeah.
need so it's
Yes.
maybe like 30 minutes.
Really?
It is a good movie.
What movie?
it's like it's only
Chariots of Fire.
Never heard of it.
I have it on DVD, but I think
Yeah.
we're doing additional math topics after this.
Nah,
No,
that
no.
sounds like a bad idea.
We have almost like a month of school.
But here's the thing though, we deserve a month of break. Because you know,
You just have fork open? Like,
Yeah.
be a thing.
Yes.
Fork
On
open.
the last day of class, can we watch that movie you were talking about with the like Hispanic teacher who like helped?
Oh, we watched that in Rado.
Yeah.
We watched that in Rado.
Oh my
back
God.
then.
Wait,
Let's get back to this problem. Hey, which formula did you use for the first step?
You do that on the same.
54?
See.
Yes. Hey, what's fun about formula 54?
You still have to.
You still have to keep going. There's an integral in it, right? So now you need another formula for the integral of x squared cosine x.
Then you get the sine integral next kind of.
Yeah, you do that.
I know. You keep going until you like, because the power keeps decreasing. X.
No, because this is gonna
And then you can go again.
Let's just hope there's not a problem with like X, but not like.
So there are I'm doing this example just so that you can see that there are some formulas where you actually have to do formulas within formulas, right? So some formulas, the answer has an integral in it. And then you have to apply a new formula for that integral,
Really happy.
right?
yeah, I know.
Wouldn't
So-
it be easier to do like that method?
I will tell you that it actually, in my opinion, the one value from this lesson is that it's making you actually kind of appreciate knowing how to do them by hand. Isn't that nice?
Yeah.
Right? Okay,
Nah.
so I'm gonna show you, if you have not learned tabular method, I am going to show you how to do it. You can learn it honestly in like 90 seconds. Are you ready? Okay, so we're gonna do the integral of x cubed sine x.
This price.
Yes.
How much work do you have to show when you're like doing an integral? Because couldn't a student potentially like memorize all the formulas?
Yeah, I will tell you, there is never a question in the free response that just says find the integral. It's always multiple choice. So if you've memorized, you can just, yeah, right? Not that the multiple choice is, 50 problems of find the integral.
Wait, it isn't? That's not fair.
Okay, so tabular method.
Probably already has.
Oh, I can't write today. Tabular. tab method. This works, have to talk, you guys. Polynomial times, and I just wrote polynomia. Okay. All right. Polynomial times a function that can be integrated repeatedly, not just once, but over and over and over. So the most common ones you'll see are a polynomial times a sine or cosine, or a polynomial times e, right? E to the x. Those are the ones you see most often. So here's how you do tab method. You make a table, and you still have your u and your dv. Your u is the polynomial, and this is the other function. So ours was x cubed sine x, right? You take the polynomial and you differentiate it down to 0. So you have 3x squared, 6x, 6, 0. You take the other function and you integrate it until you're lined up with the 0. What's the antiderivative of sine?
Negative cosine.
Alright, okay, negative cosine. So then you'd have negative sine,
Cosine.
so then you'd have cosine, and then you'd have sine. Yes.
No, never mind.
Good. Okay, there's one last step. You have to alternate these signs. So you start with a positive, negative, positive, negative, positive. Your answer is the sine times this times that. You go diagonally down. So the answer for this problem would be negative x cubed cosine x plus 3x squared sine x plus 6x cosine x minus 6 sine x plus c. Right? And that's it. Right? Isn't that nice? If you were doing this with a traditional integration by parts, you would have to do, what, 4 iterations of integration by parts, right? It'd probably take like 2 sheets of paper. So, anyway, there you go. Saving trees. Does everyone have this?
Sure, if you would.
They start with plus, and then they just alternate down. Okay, so that's it for today. What we're going to do now is we're going to take the H3 quiz.
Should we finish the other one first?
Oh, you had some